Hello, everyone. So we are continuing our series looking at how to work with the Codesys control for Raspberry Pi. So basically, we've already looked at how to install the Codesys control runtime for Raspberry Pi. And we saw in a previous tutorial how to basically configure and create a fast application and load it to your Raspberry Pi and test it out. Make sure that things are running as expected. So we are continuing, and we are now looking at some more advanced topics going forward. And today we want to see how to work with GPIOs. So I'll continue with the same program that I created last time, same project, and we shall just build on that going forward. Remember in this last tutorial we created one visualization page here, and then we had one variable here, which we were able to show the value of that in the visualization here, and then we were able to change the text as well from the visualization here, just a small test. So we are going to build on that. And just a simple recap, here I'm working with, this is Codesys version 3.5, Service Pack 20 patch 5, and it's the 32-bit version. And the runtime version for the Raspberry Pi is 4.13, and it's the Codesys control for Raspberry Pi MCSL. It's the 32-bit version there. So that's what we're working with here. I'm working with the Raspberry Pi 3B. And as you can see here, I've set up my hardware the way I'm going to be using it. There I have the Raspberry Pi here, and then I have this button matrix here that I'll be using to generate some inputs to the Raspberry Pi. So I've connected the GPIO pins to the corresponding buttons that I'll be using here. I'll be using the first column there. So I've connected everything as is supposed to be to make this work. I'll show you a little bit on how the which pins I've selected to use here. I'm using 4 pins, so I'll be using 4 buttons there. First column, as I've said already. And before we actually continue, let's first do our hardware configuration here on our device tree. So if you look on the device tree here, you'll see we have a couple of interfaces here that we can work with. We have the I2C interface, the SPI, the camera here, the one wire, and things of the kind. But our concentration today is on this GPIO interface here. Now, there are 2 things to note here. One is which GPIO device you should use, and 2 is how to change the GPIO device. So as you can see here, I have already a GPIO device attached here. So when you create a new project, this device will be attached by default. But it might not be the one you should use, depending on your Pi model. So for Raspberry Pi models A and B, this would be okay. So this is the GPIO device for Raspberry Pis A and B. So I'll put this one a little bit here. So you can see when you double click on that, you'll see that you have access to all the GPIO pins here, and you can do the configuration as you need, and then you do the mapping and things of the kind. But this is only for Pi versions or models A and B. If you are using Pi model B plus or Pi 2 and later, then you need a separate or a different GPIO device. So in order to change that, so for example, in my case, I'm using a Pi 3B plus, like I said already. So this is not the device that I really want. So I will have to right click on this and then go to update device. And you see that you have an option here. So you have 2 options. You have this GPIOs A/B, which is the device for Pis A and B. Those are the model A and model B. But then you have the GPIOs B plus / Pi 2 here, which is then for Raspberry Pi B plus or Pi 2 and then later. So that is the one you would need in this case if you are using a B plus or Pi 2 or anything later than that. So that's why I'm going to have to change this. And you see basically here, you have access to all the pins here. So it's from pin 0 to pin 31. But when you change here, so I'll go to, sorry. when you go to update device, then I select this GPIOs B plus / Pi 2, then click update here. And when I close this, now you see that we have just a selected number of pins we can work with as GPIO pins here. So that's the difference. And the reason for this is, so if I pull out this pin out diagram for the Raspberry Pi B plus and later, you'll see that we have all the pin definitions here, but some pins are reserved for other functionalities. So for example, pin 2, GPIO pin 2 is for I2C, and that is for the SDA pin. And then pin 3 is also I2C, which is the SCL pin there. And then you have things like pin 8 and 7. These are SPI or SPI 0 CE0 and then SPI 0 CE1. And then you have pin 10 and pin 9, which is for SPI 0, and that's the MOSI pin 10, and then GPIO pin 9 is the SPI 0 MISO pin as well. So these pins are reserved for other functionality, for I2C communication, for SPI communication, for serial communication as well. You can see pin 14 and pin 15 here. So you should not be able to use those pins as GPIO pins, at least for the default configuration. That's why you see here that we only have the pins that we are able to use as digital I/O pins. So pin 4, pin 5, pin 6, then we jump to 12, 13, 16, 17, 18, and you can see all of them basically here. Those are the free pins we can use as digital I/O pins. So that's the explanation here. Every other pin that does not appear on this list has been reserved for other purposes, for communication and things of the kind. So we can see right from this diagram which pins we can use. So any pin that has not been assigned in this pin out diagram, that means we can use that pin as an digital input and output pin. So I've selected 4 pins that we're going to use in this demonstration. So I've selected pin 17, because that is a free pin, pin 27, pin 22, and then pin 26 here. So those are the ones that we're going to be using in this demonstration. Okay, so now we've selected the correct GPIO device. We've identified the pins that we want to use as well. And now the next part is now to create our variables that we are going to use to capture the state of the pins there. So I'll just create an array of Boolean. So I'll say this is an array of inputs. And that will be an array of 1 to 4, because I have 4 inputs there of bool. So each of the array elements represents 1 input, and that's how we are gonna do it there. So first I create this variable, or a list of variables, or an array of variables that I'm going to use to capture the pin state there. And then we shall go ahead and in the visualization here create a very simple kind of logic here, so we can visualize the state of the pins even in the visualization here. So I'll go with, let's see, what visual elements can we use? We could use some lamps. So if I go in the lamps here, we can see that we have some lamp element here, so we can use one of those. So okay, we need 4, so I'll put all the 4 here, there. So I can also include a text to show what they represent. So I can get a label here, and then I'll say this is input. First one was 17, and then I can give this one a more deserving color here to make things a little bit clear. So I'll give this a black color, the background there, and then I can give this something like a white there, and then I can increase the font as well. Give this a 12, and then Okay, so I have input 17 here, and then we shall have input, the second one is input 27. Then we have input 22. And then we have the last one below is input 26. So that represents the pin numbers there for the pins that we are using there. And then for these, I can actually have different colors. So this, I can leave that one in orange. Then I can give this one, let's see what other color we have here. I can give it, can give it a red. Then I can give this one a green, for example. Then I can give this one a blue. Why not? Okay, now I have to attach the variables that will change the colors of, or will set these lamps on and off. And for the first lamp, I want to, this one will be controlled by the first element in the array that will be reading or will store the status of, or the state of this pin 17. So I have to browse here under variable, and then I have to select the first element in our array. So I go there, then I have this array of inputs, select that, and then I just give here the index for the array. So I want this one to be index 1. Then I should do the rest. This one will be index array element at index 2. This one will be array element at index 3. And then the last one here will be array element at index 4. Okay, now we've attached the variables that are going to be controlling these lamps. Now the remaining part for us is now to map those variables to the corresponding pins. So to do that, we double click again to our GPIO device here. Under GPIO parameters here, this one, this is where you do the pin configuration. So the pin can have 3 states. It can be not used like it is right now, or it can be an input pin or output pin. So that's what we're going to do right now here. So we want to set all our 4 pins to input pins. And the first one is that pin 17. So we identify pin 17. Here we come, and then we change it from not used to input, like that. Then we go to pin 27. We do the same thing. So input as well. Then we go to pin 22. We do the same thing. And then lastly, we go to pin 26 and do the same thing. Okay, now we've done the pin configuration there. Now we do the mapping. So we go under GPIOs IO mapping, and we identify our pins, and then we map the corresponding variables that are going to keep or read the state of those pins. So first pin 17 will be connected or will be mapped to our array element at index 1. So I'll come to 17 here, double click here, then I can browse. I select the variables, the inputs, array inputs there, but then I need the index. So I'll say index 1. Then I'll do the same for the rest of the pins. 27 is at index 2. 22 is at index 3. So 22 here, mapping index 3. And then lastly, 26 is at index 4. There. So now I've mapped the variables to the corresponding pins there, and we should now be set with our program here. Okay, so I've mapped the variables to the corresponding pins, and then I've attached those variables to the corresponding lamps here in our visualization. So we should see things when a pin is pressed, for example. The lamp should turn on. Okay, now the next part is for us to upload this program. Remember, what you should always do is come here to deploy control SL. Make sure you're connected. Make sure your runtime is running, because that's important. If it's not, then you can't have a connection to the Raspberry Pi. So I will connect again here to the runtime just to make sure that it's running and it's okay. If it's not running, then I can start it and then continue with the rest. So first, let's check that it's connected, rather that it's running. Okay, so we can see we are connected there, and then when we go under operation, we can see that Codesys control for Raspberry Pi is running as well. So we can disconnect. And then now we can come here, scan network, select our Raspberry Pi there, click OK. Okay, now we are connected to the controller there. Now we only have to upload our program. You can, of course, build to make sure you have no errors. Okay, 0 errors, that's a good sign. Now we can upload the code and then test our application here. Yes. Okay, it might take a few more seconds, but we should be there quite soon. Okay, our application has loaded, and then we can put it to run here. So run, and now everything is running there. And we come here to our visualization page. And now we should be able to test and see that things are working as expected. I'll make this one a little bit larger here so that we can see what's going on. Okay, so I'm going to press the first button on top. That should light up our first lamp there. So top, and then you can see that the lamp has turned on there in our visual page. If I release, the lamp turns on. Then I go to the next one here. I press that, and then we have our red lamp there turned on. That is the one that is connected to pin 27. If I release, that should also turn off. I go to the third button here. If I press that, then our green lamp has now turned on. And then if I release, that should also turn off. And then lastly, I can press the last button here on the first row. And then you can see that our blue lamp has turned on as well. Then if I release, it should also turn off. So that's how we can capture or work with our digital input and output pins with the Raspberry Pi here and the Codesys control for Raspberry Pi. So that's how that is working. All right. So with that being said, I think this is enough for this tutorial as well. We shall look at other topics going forward in the next tutorial. Thank you. Have a nice day.